Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you all fine. Lecture for grade 9, subject chemistry, chapter number 7, exercise, lecture number 26. And here is your lecturer, Mrs. Saira Jamal. Dear students, in this lecture, we will discuss the extended question answers. Question number 3, define oxidation and reduction in terms of loss or gain of hydrogen or oxygen atom. What is oxidation? Oxidation is gain of oxygen and loss of hydrogen atom, while reduction is loss of oxygen and gain of hydrogen atom. So oxidation and reduction are two opposite processes. Let us understand it with the help of some examples. Example number 1, hydrogen when react with copper oxide, it will give metallic copper and water. So you can see in this reaction that hydrogen undergoes oxidation by gaining oxygen atom, while copper oxide undergoes reduction by losing oxygen atom. So hydrogen after gaining oxygen atom is converted into water, while copper after losing of oxygen atom is converted into metallic copper, which is in the solid state. So hydrogen gains oxygen to become water, hence hydrogen undergoes oxidation, and copper oxide loses oxygen to form metallic copper, hence copper oxide is reduced. Since both reduction and oxidation occur at the same time, so this type of reaction is called redox reaction. Redox reaction is said to have taken place. Second example is reaction of carbon monoxide with ferric oxide and which is converted into metallic iron, and carbon monoxide is converted into carbon dioxide. So carbon monoxide is oxidized. You can see here carbon has one oxygen atom, but at the product side it has two oxygen atoms. It means carbon gain oxygen atom, and gaining of oxygen is called oxidation. And iron, you can see, loses oxygen atoms and converted into the metallic form. So loss of oxygen is called reduction. So carbon monoxide is oxidized as it gains oxygen atom, and iron oxide undergoes reduction as it loses oxygen atom. As both reduction and oxidation take place in the same chemical reaction, so the reaction is said to be a redox reaction. Here iron oxide is the oxidizing agent and carbon monoxide is the reducing agent. Example number 3, reaction of hydrogen sulfide with chlorine gas, which will give hydrochloric acid and metallic sulfur. So you can see that in this case, sulfur is losing oxygen atom, or hydrogen sulfide. In case of the hydrogen sulfide, it is oxidized as it loses hydrogen atom, and loss of hydrogen is called oxidation, while chlorine gains the hydrogen atom. So in this case, chlorine is reduced by gaining hydrogen atom, because gaining of hydrogen is called reduction. So chlorine is reduced as it gains hydrogen, while hydrogen sulfide is oxidized because it loses hydrogen. Similarly, this is also a redox reaction with both oxidation and reduction takes place at the same time. So as chlorine undergoes reduction, so it will act as an oxidizing agent, and hydrogen sulfide undergoes oxidation, so will act as a reducing agent. Question number 4, define oxidation and reduction in terms of loss or gain of electrons. Oxidation, a process that involves the loss of electrons by an element, is called oxidation. For example, group number 1A, which are called alkali metals, and group number 2A elements, alkaline earth metals. These elements loses 1 and 2 electrons. Alkali metal loses 1 electron, and alkaline earth metals or group number 2A element loses 2 electrons respectively to form cations. In doing so, these metals undergoes oxidation, because loss of electron is called oxidation. So sodium is present in group number 1, it will loses 1 electron and will form monovalent cation. Sodium is oxidized by losing one electron. Calcium is oxidized by losing two electrons and will form divalent cation. Other examples of oxidation are iron, and after losing two electrons, it gets oxidized by forming ferrous ion, or the ferrous ion then further will lose one more electron to convert it into ferric ion. And copper, after losing two electrons, is converted into cupric ion. So all these cations formation after losing electron by a metal is called oxidation, because oxidation is loss of electrons. A process that involves the gain of electrons by substance is called reduction. Reverse of oxidation is reduction. Oxidation is loss of electrons by an element or by an atom, while reduction is gain of electrons by a substance or by an element or an atom. For example, elements of group 6A and 7A. Group 6A has 6 electrons in the outermost shell, and group 7A elements have 7 electrons in the outermost shell. So in order to complete their octet, group 6A elements having 6 electrons will gain 2 electrons and will form minus 2 ions. And 7A will gain only 1 electron and will form minus 1 monovalent anion. And group 6 elements will form divalent anion. So chlorine, after gaining 1 electron, will form monovalent anion. Oxygen is present in group number 6, so it will gain 2 electrons to form divalent anion. Sulfur, same like oxygen, because both are present in the same group 6. So both of them will lose 2 electrons and will form the anion. Oxygen anion and sulfur anion. Question number 5, list the possible uses of electrolytic cells. Uses of electrolytic cell. The first one is down cell. So down cell is used for the commercial preparation of sodium metal. It produces fluorine gas as a byproduct. Down cell, we have discussed it before, that down cell is used for the preparation of sodium metal from the molten sodium chloride. And Nelson cell is used for the commercial preparation of sodium hydroxide. It also produces chlorine and hydrogen gas as a side product. Electrolytic cells are used for the commercial preparation of calcium and magnesium metals. It is used to produce aluminum metal commercially. It is used for the purification of copper. Electrolytic cells are used to electroplate metals such as tin, silver, nickel, etc. on stainless steel or on steel. Question number 6, sketch a Daniell cell, labeling the cathode, anode, and the direction of the flow of electrons. So in this image, you can see we have a Daniell cell, which has zinc electrode dipped in zinc sulfate solution and copper electrode dipped in copper sulfate solution. And the two electrodes are connected with the voltmeter. The voltmeter will tell us about the current which will produce during this reaction. There is a Searle bridge. This function of the Searle bridge is to control the ions balance between the two beakers, and you can see that the electrons are moving from anode towards the cathode. Anode will act as you can say at anode oxidation will take place, and at cathode reduction will take place. The only difference in electrolytic cell and the Daniell cell is that you can see that the cathode is mentioned with positive sign and anode is represented by the negative sign. Next question is by, we have an electrolytic cell, and in this electrolytic cell there is a key. So if we want to complete the circuit, we will close the key. And if we want to disconnect the circuit, we will open the key. So if we will open the key, then no reaction will take place. So the question are, in which direction do electrons flow when the key is pressed? When the key is pressed, the circuit will complete it and the electron will start flowing from anode towards the cathode. So electron leaves the zinc electrode and then move towards the copper electrode, which is cathode. Oxidation takes place at which electrode? Oxidation always takes place at anode, which is a zinc electrode. Reduction takes place at which electrode? Reduction always takes place at the cathode, which is a negatively charged. In this case, it is positively charged electrode. Then, in which half cell do electrons enter the cell? Electrons enter the cell at copper electrode. Electron enter coming from, because zinc is leaving electron will move from zinc and will enter into the cathode, which is made up of copper in this case. Reduction takes place at which electrode? Reduction takes place at the copper electrode. In which half cell do electrons enter the cell? Electrons enter the cell at copper electrode. Electrons are consumed at which electrode? Electrons are consumed at cathode, right half cell. At cathode, because from anode electrons come there to utilize at cathode. Which electrode is negatively charged? In case of the Daniell cell, I told you that the negatively charged electrode is mainly the cathode, but in Daniell cell or in Voltaic cell, the anode will be negatively charged, and in this case, anode is zinc electrode. Which electrode will decrease in mass during operation of the cell? Zinc electrode will decrease in mass because zinc atom loses electrons. Which electrode will increase in mass during operation of the cell? Definitely cathode. Copper. Copper, which will act as a cathode, will increase in the mass. Suggest a solution for the electrolyte. Zinc dip in 1 molar zinc sulfate solution and copper dip in 1 molar copper sulfate. So this is compulsory that we have to use the electrolyte same as the atom which is forming the electrodes or which form the electrodes. In which direction do cations within the salt bridge move to maintain charge neutrality? Negative ions move from cathode compartment to anodic compartment to the salt bridge. In this way, the solution of two half cells remain neutral. Salt bridge contain potassium chloride salt. The cation potassium of salt bridge move towards copper electrode and chloride ion of salt will move towards the zinc electrode. Question number 11, give balance half reaction and overall reaction. Right half reaction is when copper, like we say, right half reaction where copper gets produced after gaining two electrons. You can see copper after gaining electrons is converted into solid copper or metallic of copper. Then the second half cell is zinc. Zinc metal strip dip into 1 molar solution of zinc sulfate, will giving the following equilibrium reaction. Zinc after losing two electrons converted into zinc ion, and the overall reaction is up zinc metal when react with copper ion, it will form zinc ion and metallic copper. Zinc will convert it into ion and copper will convert it into a neutral atom or into metallic solid. Again, the reaction is redox because oxidation and reduction takes place simultaneously. Question number 7, describe how a battery produces electrical energy. So a battery is a galvanic cell or a group of galvanic cells joined in series. It generates electric current by a redox reaction. When connected in a circuit, its anode oxidizes by releasing electrons. These electrons through the external circuit begin to flow towards the cathode. At cathode, these electrons reduce oxidizing agent present in the electrolyte. Example of batteries are dry cell, storage cell, and mercury battery. Question number 8, describe the method of recovering metal from its ore and or describe the method of recovering iron from its ore. Method of recovering metals from their ore, the process of producing a metal from its ores always involves oxidation reduction reaction. Most of the metals are found in nature as oxides or sulfides, or after mining, the oxides are reduced to free metals by using a reducing agent. Use of reducing agent, we can use carbon monoxide as a reducing agent, hydrogen as a reducing agent. So we can use carbon monoxide, hydrogen as a reducing agent for this purpose. You can see in this image, blast furnace is used actually for the uh, uh, extraction of matter from its ore. You can see this furnace, which is called blast furnace, because hot air is introduced into this blast furnace with a blast. And slag, the impurities are collected here, and the pure iron, molten iron is collected at this side. And these are the gases which are produced during the furnace, and they are going upward. And then definitely the charge which has been added in this case is iron ore, limestone, and coke. Coke is the carbon. For example, extraction of iron involves the chemical reduction of hematite. We mostly use the hematite for the extraction of iron from its ore and by coke in a blast furnace. Charge, what is charge? Iron ore, limestone, and coke are introduced into the blast furnace from the top. So a blast of air is forced up the furnace from the bottom, hence the name blast furnace. It is then due to that blast of air which is introduced from bottom, this furnace is called blast furnace. Waste gases, the oxygen gas react with coke to form carbon monoxide and some carbon dioxide. These reactions are highly exothermic. As hot carbon monoxide rises, it reacts with the iron oxide and reduces it to iron. You can see the carbon monoxide which is formed, it will react with the iron oxide and will reduce iron oxide by losing oxygen atom to form metallic iron, and carbon monoxide will convert into carbon dioxide. So as hot carbon monoxide rises, it reacts with iron oxide and reduces it to iron. Molten iron collects at the bottom of the furnace. Limestone removes impurity from the iron as a slag. Limestone will react with the impurities and then will form slag, which will settle down at like which have a layer on the metallic or the molten iron, and then we can call it a slag. This is the slag, this layer is slag, and we can remove the slag with this opening, and the molten iron we can collect it through this opening. Extraction of lead and zinc metal, like iron, we can extract the other metal as well from their ore, like by using the like those reducing agents. So the reducing agent will react with the ores of lead and with the ore of zinc and will give metallic zinc, metallic lead, and metallic copper. In this process, sulfur is oxidized and oxygen is reduced. These oxides are then reduced by coke or carbon monoxide or hydrogen. Now, in this case, zinc oxide with carbon will form carbon monoxide, lead oxide with carbon monoxide, carbon dioxide, and copper oxide with hydrogen will give us copper, metallic copper, and water. So, coke, carbon monoxide, and hydrogen, all these three can act as a reducing agent, and they help in the reduction of these metallic oxides into their pure form. Question number 9, explain electrolytic refining of copper. Electrolytic refining of copper, it contains impurities such as zinc, iron, silver, and gold. So these impurities are removed by the process of electrolysis. In this process, pure copper bars act as a node, and uh, the impure copper act as an anode, and the pure copper will act as a cathode. So copper sulfate solution with little sulfuric acid is used as the electrolyte. Why we are using little sulfuric acid? I told you that to prevent the process of hydrolysis, we will add little sulfuric acid in the electrolyte along with copper sulfate. So this is the pure electrode which will act as an anode, and the impure electrode will act as a cathode. So what will happen when the switch is on, when the battery is on, the zinc will loses electron and will leave electrons on the anode, and then it will move to the external circuit into the second or into the bar, which is the pure copper bar, and this pure copper bar get increased inside due to the deposition of the copper which is coming from the inner side. Working of electrolytic cell on passing electricity, copper anode dissolves forming copper ions, and cation move towards the cathode at which they only in which the only copper ions are reduced. The spare copper deposit at cathode. The less electropositive metal like silver and gold they form bottom of the cell. Copper obtained in this process is 99.5% pure. And reaction are copper, metallic copper will oxidize by losing electrons, and then the copper ion will reduce at cathode by gaining electrons to form pure copper or solid copper. Question number 10, compare the effect of aluminum oxide and ferric oxide formation on their parent metals and cite examples from daily life. Corrosion of aluminum, the corrosion resistance of aluminum is dependent upon on a protective oxide film or oxide layer of aluminum oxide which is formed. So this film is stable in aqueous media when the pH is between about 4 to 8.5 pH. The oxide film is naturally self-renewing and accidental abrasion or other mechanical damage of the surface film is rapidly repaired. So this does not occur, like we are expecting that the other aluminum substances will also corrode out, but I told you before in the previous lecture that the layer of aluminum form is very tough and insoluble aluminum oxide layer, and it will prevent the rest of the aluminum from the corrosion or from reaction with atmosphere. So on the other hand, the insoluble layer of rust in case of iron oxide that form on the surface of iron is too porous to protect the underlying metal. So this layer flex away and exposes metal for further corrosion. Aluminum is extensively used in the construction of aircraft, ships, cars, cooking utensils, window frames, soda cans. Aluminum has much higher tendency to oxidize than iron. Therefore, we might expect to see aircraft and ships, cars, cooking utensils, soda cans transform into piles of corroded aluminum. But I told you that aluminum oxide layer which is formed is very tough and hard layer, and this upper layer of aluminum oxide will prevent it from further oxidation. Rusting of iron is an example of corrosion. So rusting is a chemical process that can take place in metal exposed to the atmosphere. Iron kept in moist air for a long time gets rusted. The rusting is due to the coating of hydrated ferric oxide on the surface of the metal. Impurities present in the metal facilitate rusting. So the presence of carbon dioxide in air also helps rusting, and along with hydrated oxide, rust also consists of carbonates. Condition for rusting, I told you of presence of oxygen in atmosphere and moisture in atmosphere are the causes of rusting of iron. So iron when at the anode will lose its electrons to form ferrous ion, and another region which is called the cathode, the electrons released in the oxidation process reduce the atmospheric oxygen to hydroxyl ions. The iron ions formed at the anodic region flow to the cathodic region through the moisture on the surface. Here, iron ions further react with oxygen to form rust. That is, formula is ferric oxide with X water molecule. X means the water molecule varies. In this image, although I told you about this image in my previous lecture, but I'm just giving a quick review. In this image, you can see that the iron bar, it will act as an anode because here there is less content of water. So at this point, iron will get oxidized by losing 2 electrons. But the iron which is close to the surface and the surface has water vapors and oxygen over there. So the surface oxygen or water vapor react with the oxygen atom and will gain 4 electrons per iron. One iron is giving 2 electrons. So 2 iron, because in the formula you can see Fe2 means there are 2 irons. So 2 iron will have like the 2 iron will give 4 electrons. One iron will give 2 electrons and two iron will give 4 electrons. Oxygen will react with water and will, by gaining 2 electrons, will convert it into 4 hydroxyl ions. And you can see oxygen with hydrogen and with 4 electrons will give water. Now you can see that the iron after losing electron is oxidized, and oxygen after gaining electron is reduced. Explain how food and beverages industries deal with corrosion. Tin plated steel is used to make food cans. Food and beverages industries use these tin plated steel cans. This is because the components of food, beverages, and preservatives contain organic acids or their salt, and they will react with the iron, iron canes. What will happen then? They will form toxic substances or toxic food. And these acids and salts are, very corrosive, very dangerous for health. So tin plating is non-poisonous and it prevents corrosion. You can see in this image that most of the food cans, they are made up of steel, but tin plated steel. The layer on the steel is of tin, metal tin. Hope you understand this lecture. Inshallah, we'll continue this exercise. Some of the questions and think tank is left. Inshallah, we will do it in our next lecture. Till then, take care. Allah.